transfers a growing polypeptide chain onto an amino acid. And so we'll look at that process today a little bit. It occurs inside the ribosome, and unfortunately I forgot my paint today, but I am going to paint the top of that board white as soon as I remember. But don't tell anybody if they ask you how that happened. Don't tell them it was me. The ribosome has two major subunits, what's called the small subunit and the large subunit. Now they're made up of lots of different proteins and, interestingly, lots of RNA. And in fact, the RNA outweighs the protein 2 to 1 or more. It's a lot of RNA stuck in there. That's where these ribosomal RNAs come from. They're highly produced in the cell. If you actually purified RNA from the cell and look at it, 50% of it would be ribosomal RNAs. And the only purpose they have is to form this ribosome. Interestingly, though we're not going to get into that mechanism, it's the RNA that catalyzes the peptidyl transfer. So these are ribozymes. They're RNAs that have enzymatic activity. Anyway, turns out that the small subunit and the large subunit don't interact with one another unless they're also bound to a messenger RNA. So they're floating around inside the cell in distinct subunits, large and small, just floating around. And then probably Dr. King told you that RNAs bind along with a transfer RNA carrying the initiating methionine to an RNA. So it's the small subunit that recognizes the RNA and binds the first tRNA, the transfer RNA, the RNA that brings amino acids to the ribosome, to itself. And once that complex is formed, then the large subunit can sit down. I haven't depicted all those details here, and I won't test you in all those details, but I presume you've already learned about them. Once that ribosome has fully formed and becomes active, then it starts moving along the messenger RNA, recruiting additional tRNAs, binding them to the RNA based on codon-anticodon pairing, which is another idea I'm sure you've considered before, and then brings in amino acids. And so when the complex is fully formed, there's actually 3 tRNA binding sites of A, P, and E. And the A, P, and E stand for something. The A stands for aminoacyl. Let me write some terms down, I guess, since we're going to use them. The A stands for aminoacyl. And you might guess that's where the amino acids come in. The P stands for peptidyl. Peptidyl. And then E is for exit. So a ribosome can hold up to only 2 tRNAs at one time, though it has 3 binding sites. And I'm not going to get into the mechanism of that either, because I presume that's King's topic. But if we look at the next slide, what we see is, this is beautiful. So there's the fully formed ribosome at the top. And then we have, in this case, what I haven't shown you is the first tRNA. The first tRNA binds to the small subunit in the future P site. And of course that will have the initiating methionine stuck to it. So the complex of the active ribosome does have a tRNA already bound to it, and it's bound in the P site. That leaves the E site and A site open, and the A site oh, you little bastard. I don't want to get stuck. Is there a transfer? amino acid comes into the A site. So once this is formed, now a tRNA,
Oh, it's still alive.
and the tRNA is the one that has the anticodon on it, stuck to a new amino acid, comes into the A site and sits down and brings with it its amino acid. In this case, these little balls are representing the amino acids. Is it still alive?
Yeah.
Really? Are we suffering?
Ooh.
I'll clean that up later.
I think I got that crunch in HD.
Did you hear how crunchy it
Yeah,
was?
I did. It was nice.
If you were starving, you would eat that.
I don't think so.